Hello everyone, today I'll show you 8 tips and tricks that will help you to have a better performance from your PCG graph, cleaner graph with less nodes doing the exact same thing, how you can change the look and the generation of your PCG graph based on some variables, and how you can manipulate the points that your PCG graph generated in your blueprints. So let's start with the first one. If you want to create some PCG node and you want to have random missing elements, like for example in this fence, you can see that here it's missing a piece. Usually this is done by creating an attribute noise and then filtering by the numbers, for example for the density attribute noise. But there's a simpler and more clean way that you can have your PCG graph looking a little bit nicer and easier to understand, and you can have fewer nodes. So I'll show you this right now. So I created this blueprint just to have a head start. So it's a blueprint with a single spline and a PCG node connected to this PCG fence tutorial graph. And this PCG fence tutorial graph is sampling the spline and placing an element every 7 units, and then transforming the element, rotating so it's facing the upwards direction. And then you are placing 2 pieces, these wood planks, vertically. Instead of adding an attribute noise here between the transform points and the mesh spawner and then a filter based on some attribute, you can just add here an empty element which will generate these random missing spots in your PCG graph by controlling then the weight of the distribution for these elements. So for now, all are set to 1. So you have an equal distribution of the smaller plank, the longer plank, and the gaps. If I put 5 for the first value, I have a lot more items from the smaller plank. If I put 10, I have a lot more than with the bigger one. And the weight for the gap is controlling how much gaps I have in my fence. So let's say we'll have 10, 5, and 1. And this way you can see that your graph stays a lot simpler. You can, to be sure that you're not losing any performance, go into the descriptor node. Here you have no static mesh connected, but just to be sure that if you, for example, connect some static mesh and you don't notice, it's, for example, some smaller mesh and it looks like it's fine, or it's transformed somewhere that you can not see it. But just to be sure that you're not losing any performance, go here into the attributes, remove the cast shadows, remove the visible check mark. So that way it's not going to appear as any element in your scene. You have these perfect gaps in your PCG graph with this simple graph, and it will be calculating a lot faster, not needing to have applying a noise and then filtering this element, removing points. And that's it for this tip, and let's continue with the next one. So let's see the second tip for this PCG graph tip. So it's helping you randomize the look of your elements by recomputing the seed for a specific node. So you can see that I created this example. We are placing the vertical elements at a given distance, for example 21 for now, for this fence, and we have 2 rows of our horizontal pieces. So the first row is transformed 15 units from the bottom, and the second one is transformed 50 units from the bottom. And we have the same setup as in the previous tip, where we have an empty element to get this more randomized look. And the problem is that we always have the same place where we are missing from the bottom and the top part. So it looks like our fence is not connected to anything. In order to avoid this, you want to have a different seed for these two transform points node, which are generating the two rows of our horizontal pieces. So mark this one of these elements and change the seed number, and also enable this recompile seed checkbox. So now you can see that we have a different seed with different randomly placed boards for our top and bottom row. In that way, we can have a fewer chances of having this both pieces missing. If I place a bigger weight for the board than the gap, so we have fewer gaps. And now you can see we have this better random placement for our horizontal parts. We can add some randomization in the placement in the vertical node. So now our fence look a little bit better. We can change here the boards to be a little closer together. So this is the second tip, how you can change the seed of your random elements so you can avoid having the same repetition on two sets of points. Let's continue with the next tip. So for tip number 3, I'll show you how you can select the last index of our PCG graph, so you can control how this fence ends, because for now we have our spline ending here, but when we place these horizontal pieces at the end of the spline and we rotate them, they are stretching out from our fence and they are not connected to any vertical pieces. So we want to avoid that. And to be able to do this, you can go here in this spline sampler. Let's disconnect it from the transform points, which are moving our points for the two horizontal rows. And let's first copy the index attribute of our points. So let's copy the index into a new attribute. Let's call this index. It will be our custom index, not the one coming from the actual points, because it's changing based on our operations. And we want to save it when we are generating the points from the spline. So we are saving the current index into our custom index. Then let's attribute select. And let's use our custom index attribute and let's select the max. So if I click the A key here on this copy attribute node and here at the bottom I select my PCG graph, I can see all of my points have copied this index value into the custom index column. If I mark the attribute select node and click the A key, I have only a single point with an index value of 9. So this is selecting the last part of our PCG graph. Now, when we have this selected, let's do a difference node from all of our points. Do a difference by this last point, and only then spawn the elements like we have before. So now you can see we are no longer having these hanging pieces at the end of our fence. So this is tip number 3, how you can control by the index of your element the placement of your static meshes, so you can avoid these unwanted artifacts in your generation. So let's continue with the tip number 4. Tip number 4 is that you can actually use a branch node similar to blueprints in your PCG graph. So into my blueprint that contains this PCG graph, I have created a variable here called isReady. it will control if my fence has the built look or it's just unfinished. So this is a Boolean property which is starting with the default value of false. So compile and save this blueprint and go into our PCG graph. Let's now create here a branch node. This branch will get actor property. This actor property will be our isReady variable. So make sure this variable is public in your branch, and into this getActor property, enter the name for the property. Expand this branch node, connect it to the output to B. So if our property says that the fence is ready, we'll output to the B, and if not, we'll output to the A. So let's connect our A output, which is our default one, the false statement, to our current nodes. And let's do another spline sampler to connect to our B node for our vertical pieces. And let's change this sampler to distance of 7. And now let's save this and change the value in our scene so we can see the difference. So let me minimize this. Let's go here into the PCG fence tutorial item, and here you have the isReady variable. If I mark it, you can see that my fence is a lot more denser than it's with the other node. So let me just connect the horizontal pieces as well. So here, output B will do. Actually, let's leave the horizontal pieces the same. But now, with this branch node, you can easily control the look of your blueprint with this variable. So for tip number 5, you can use a switch node in your PCG graph. So instead of using this branch node, let's do a switch. Let's do this switch a type of integer, and let's add a couple other elements. So we'll have an integer of 0, 1, and 2, and let's connect the default of 0 to our default spline samplers. Let's connect the 1 to the more dense spline sampler, and let's connect the 2 to our last sampler. And for our last one, let's say that we'll spawn meshes without these gaps in the fence itself. So let's delete this empty element. Let's save this. And now we need a variable to connect to this sampler. So let's go into our blueprint. Let's connect a build level variable. Let it be an integer. It will be a default value of 0. Let it be a public. Copy this name. Compile and save the blueprint. And here we'll get the actor property with the name build level, and we'll connect it here into the integer selection field. So expand this and connect to the integer selection. So now if I go into the level, I select my blueprint, I go here into the details panel, this build level. If I change it to the different values, it will use the switch node to control the look of my fence. So let's continue with tip number 6. I'll show you how instead of using a variable, you can use the setting for the PCG quality to control the look of your PCGs. If you want to have a setting in your menu, for example, how detailed are the PCGs, let's delete this switch and the actor property, and let's use a runtime quality branch. The points from the spline data here will be outputting a different pin for our different kind of setting. So for our wall setting, we'll spawn a wall amount of points. For our medium, we'll spawn more, and for our higher levels, we'll spawn the full amount of elements for our fence. And here, let's do the wall and medium for this top branch, and our higher with this denser field without the gaps of the horizontal level. So now the problem that you see here, the warning is saying that our PCG node is not set to runtime generation. So go back into the blueprint, select the PCG, and here for the generation trigger, let's select generate at runtime, compile and save this. And if you go at the begin play event for your blueprint, let's get this PCG by control dragging here. Let's do a cleanup, connect it to the begin play. Then after this cleanup, let's do a generate for the same PCG node. So now if I compile and save this, let's do PCG dot quality and then 0. Now you can properly see that we are changing based on our PCG quality, PCG dot quality, then 1. We have now the denser fence, and if I change the quality to something bigger, PCG dot quality 2. Sorry, I didn't. Now we have our runtime select running to the last node, so it's generating all of the pieces from our fence. For PCG tip number 7, I can recommend you this tip that you can place a hidden object in your scene that can be used for collision. That way you can have a much simpler object to use for collision and have your game perform much better. So now I don't have any collision in my level for this fence. I can go into the models for these wood boards and add a collision for each board, and then I have hundreds of collision objects into my scene here. But instead of this, you can go into your PCG graph. You can output spline sampler. I'll connect it for all of the levels currently. And this spline sampler, it will use transform points and then static mesh spawner. And for this static mesh spawner, I created a simple cube. Let's add it here into the mesh entries, into the descriptor. Let's connect this cube. And for this spline sampler, let's use distance and distance of 70. The cube is 70 units long. So if I hit play, you can see I have cubes generated with the collision. And if you don't want these cubes to be visible in your game, just open here this descriptor, go down here into the visible checkbox and click it. So that way it will hide the cubes, but the collision will stay. So you no longer can pass through this wall, but it looks exactly the same and it's not having a collision for every single piece of a board that's creating your fence. You have, for example, 10 cubes instead of this full fence of hundreds of boards. So this is for tip number 7. For the last tip, number 8, it's a little bit more advanced. So it will show you how you can control the points that you generate from your blueprint class. So in the class that we are generating our blueprint containing this PCG element, let's go after this generate node and let's right click here, get components by class. So make sure this is components and the type is instanced static mesh component. We'll get some just some of these elements, because if I select this blueprint, you can see that it's creating a couple of these instant static mesh nodes. Let's start with the first one, just to show you what's doing. You can manipulate the logic of your blueprint to do what you want, but just let's make an example here. So here, let's get the instance count. This is the number of instances into this instant static mesh component. So we'll decrease the number, we'll subtract 1, and this will give us the number that we can loop through. So do a loop for loop, and this for loop, the max number will be the count of our elements -1, and for each element, let's create a timeline. Actually, let's create the timeline here. We need to have it run this entire script. So let's disconnect this. Let's do a timeline. And in this timeline, let's play from the start. Double click the timeline. Here, let's create a float track. Let's do it 2 seconds long. Let's add a point. At time 0, the value will be 0. Let's add another point. At time 2, the value will be -90, because this is the value of our rotate X to have the look that we have currently into our fence. So let's go back into the event graph. So this update function, it will start this for loop. Let's rearrange the elements a little bit better here. Let me zoom so you can see better. So now we are getting the number of elements into this instance counts. Here we loop through all of them with this timeline selected. So for each of them, let's drag out of here and do get instance transform. Let's drag again and update instance transform. So let's connect this loop body here. The index that we'll get will be used from the loop, both of our get instance transform and update the transform. So let's split these transforms. We'll use the original scale, original location. Let's split the rotations. We'll use the original rotations of X and Y and Z. And for the X rotation, we'll connect our timeline node. So compile and save this. And if we play our level, you can see that we are animating our elements. I have selected more of the elements that I wanted to, but anyway, you can just change what element you select here. Let's say we'll use the static mesh with the index of 1, and let's try better. So now I have only some elements from the vertical pieces that are animated, and you can change the timeline speed, for example, or the timeline length if you want faster animation. So let's go with a length of 1, and for the values let's change this time to 1, compile and save, and now I have faster animation. You can see how my fence is being built. You can use this, for example, for real-time strategy games if you have animation for your buildings being constructed and something like this. So this is the last tip for now. I hope these 8 tips help you to create more advanced graph into PCG, because it's a great system, and let's hope that they continue to improve it. If you have some questions or some other ideas for tutorials, please write in the comments. If you like this, please consider joining the channel to support me. It will help me a lot to continue making these tutorials, and I'll see you in the next one. Bye guys.